have multiple tools. The next one we're going to look at is a centroid. And a centroid is closed contour processing. We would use this on solder bumps or something of that nature. And what it does is it calculates the size as well as the area. When I click inside, what it did is imaged everything that it saw, and it calculated the area of the physical inside of that circle. Now if I tell it to measure a circle and click inside, it also gives me the physical size of the circle as well as the XYZ position. So we can take a weighted feature, something, if the circle wasn't round, if the circle had an irregular shape, I could still find the weighted XY center using the centroid target. The last target we have is trace. And the way trace works is we tell it where we want to start, where I want to end, and I'm just going to tell it to measure this radius, and then I tell it the point spacing, and I can tell it every 1/1000th of an inch I want a point. Or if we go to metric, we'll tell it every 10 microns I want to take a point. And all I do is hit trace now, and what it's physically doing now is it just measured 271 points across the outside arc of the part. So we can give it a very close spacing and have it measure for us without us having to go back and pick features. Where this becomes beneficial is on very short arc segments where it's very hard to get anything repeatable because of the variability in the math that exists because of that short arc. We can take a very high density point spacing and get very repeatable results on small arc segments. If we go up to the top, we have pull down menus, and we've been looking at targets and tools. If I pull the target, pull down menu down, we have everything that we saw in the icons. And the tools exist the same way, but a little bit of difference, and now we have the ability to get the probe and the laser, which we didn't go through in the icons, but we'll do that in the second part of the video. Just to skip around a little bit here, we have, in part setup, we have some other interesting things. This is where we determine how we want the system to physically work, what we want it to show us while it's working. Right now we have display all windows and display all image graphics turned on. If we were running a program and doing production work, I'd want those windows turned off because I'd want the machine to run as fast as it can. If we're measuring multiple parts, no one has to be at the machine, and there's no reason to be displaying the graphics. Also, if you're going to do multiple parts, we can set up multiple parts two ways. If we have parts on the table that are not equally spaced, I can put in the XY offset between each part, and the machine will automatically go between one and another. If I have parts on a fixture that are equally spaced, I can put in the X offset between the parts, the Y offset between the parts, and then depending on the number of rows I have in the X and Y axis, I would put in the number of times that I want it to go that offset the number of times in each row. We can tell it that we want to repeat the X or Y offset first, and then we can tell it to start at step 1 or any other step. And where you might do this is if I had an alignment on a fixture, and then I'm measuring my parts based on that alignment. I wouldn't want to go back and remeasure the alignment each part, but I still want to maintain that in the program. So I may measure it the first time, and then I might start my part program. If the alignment took 10 steps, I would start the part program running at 11 rather than 1. So just a little bit of flexibility. We can also put some conditions on the part. I can tell it to stop if we measure something out of tolerance, continue to run if it misses a feature. If you don't have a feature there, or if a feature is missing, do we want to continue and just put some arbitrary number? I can put all 9s as a result if a feature was missing, rather than have the program stop if it was long. I can allow step completion after minimum data entry. And what minimum data entry is, for a circle I need 3 points. I may have used the strong edge circle where I told it 10 points, and because the feature was bad or it couldn't measure the edge for some reason, do I want to go on after those 3 points? Last thing, to force the machine coordinate system at the start of the run. We can set up a datums, or set up a part or a fixture datum in the machine. When I start a run, I may not want those to be there, so I can say force the machine coordinates back in so that I have to start fresh again. So just some of the flexibilities you can have in the machine. Again, we looked at run options. We look at run overrides quick. When I print something, normally we're going to tell it to print out what we want to see in our inspection report. And that's fine for most instances, but if I'm having trouble with a part, then maybe I want to print out all measured values that I have in the program. If I'm just going back and I'm checking a part for proper execution, maybe I don't want to print out anything, so I could check nothing. Or I can tell it to print out only the tolerance values, only out of tolerance, and I can print the elapsed time of the run. This lets you monitor people progress where intervention is required in the program. You may be requiring the operator to put in a lot number or something for statistics so that you can identify a serial number on the part. You may want to go back and have them measure something on the part and have it included with this routine. So maybe we measured the surface finish on a profilometer, but you want that information in the inspection report with the part. And we can have a manual data entry step that will let the operator put in whatever value he measured during that surface finish measurement and have all of the data in the same file. Again, print elapsed run time will let you know exactly how long each one of the runs lasted. We can send the data to a printer, to a file, any logical database, Access, Excel, anything that you would normally use. We can type in setup instructions, and again, when we create programs, we need to tell the operator how to put a part on the table and how to start the program so that it will run. Under part setup, again, we have header and footer information. And again, this is the standard header and footer information that you'd have on any file or any document, so that you can identify. Maybe the header information is your company name, the footer information could be the person's name, the shift, whatever you want to put in. It would show up on the printed document. If we go back to measure quickly, I'm backing up here, and again, these icons we're going to see over in the measure icons here. And we have point, line, circle, distance, midpoint, which is symmetry, min-max average, contour, and centroid. And then we have the 3D features. Again, the 3D features can be measured with the touch probe, certainly. We can also measure a plane with the video focus or measure a plane with the laser. We can measure a sphere with the video focus or the laser. Cylinder and cone predominantly require you to use the touch probe. We also have two more that are blanked out on the bottom of the screen right now. The bottom one being a rotary axis, which would be your fifth axis on a machine. And the rotary axis gives you the ability to position the feature you're looking at your part automatically within the field of view of the camera. So if I wanted to head a round part with holes in it, and I wanted to measure on the top of the part, and then I had another hole 90 degrees off to the side of that, I could rotate the rotary 90 degrees and that hole would be up now in a measurable position. What the digital I/O lets us do is control the machine, control an external apparatus on the machine. I could control a PLC that had an automatic loader-unloader for the machine, so that if we were loading the machine automatically with parts, the digital I/O could tell the PLC when the machine was in a clear position, when the inspection was complete, when it was time to load or unload the machine. If we go back to the units measurement, in the units we select inch or metric, Cartesian or polar coordinates. For your angular measurements, we can have decimal degrees or degrees, minutes, and seconds, and then we can select the resolution that you want to physically print out or show up on the screen. Currently we have it set to 4. We're in millimeters and we have 4 decimal places on the screen. If we go back to view, we have the image, and right now the machines are set up just to measure only with the camera. We don't have an auxiliary camera on the machines. Now you could have a second camera reading a barcode, for instance, on the machine. There's a lot of other possibilities you can put into a machine, certainly, depending on some very specialized application. When we look at the model is a 3D model, so we can physically select the view that we want to see in the model. And then we can look at the actuals, the nominals, point data, and we can turn any of these on or off that we're looking through. Overlays and masks. We can create overlays of parts so that you can compare one part against another, or a piece of one part against another on the system. And the DRO font, certainly, we give you the ability to change the fonts that you see, whether it's in the DRO, the print data listing, or the editor. You can change your fonts to be whatever you're comfortable with.